we're going to be looking at, in this video specifically, multiplying and dividing fractions, but they're rational functions, okay? So it's a little bit like going back to 5th grade when we were multiplying and dividing fractions, only this time we have polynomials, not just numbers, okay? So let's go ahead and begin with first simplifying rationals. So when we're simplifying, just like before, and I'm gonna give you an example. Let's say that we had like 24 over 50, and I asked you to simplify it, okay? Simplify just means basically just reduce it to its lowest terms, okay, to its lowest factors, okay? So when I look at 24 and 50, I want to see what factors do they have in common. And if I were to list them out, I could say 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Those are all the factors that these have on top if I were to break it up into all the factors. 50, you have 1, and 50. You have 2 and 25. You can't divide by 3 and you can't divide by 4 because you'll have remainders, but you can divide by 5. So you can have 5 and 10. So these are factors of 50. So when we are simplifying or reducing, our goal is to cancel out the biggest factors that they have in common, okay? And you can approach it by trying to think which one would be the biggest factor, or you could just break it down bit by bit by bit, okay? So the biggest factor that I see right now between the top and bottom that they share the same factor is this 2, okay? There aren't any other numbers that they share in common. So if I were to break 24 down by 2, I'm going to divide by 2, and then on the bottom I'm going to have 25, okay? And here I can't reduce it anymore. So this is fully simplified because there aren't any other factors that are in common. But again, we want to simplify always by trying to find the biggest factor that they have in common. So let's go ahead and go to this polynomial. So since we broke up between multiplication up here, in other words, we had something that looked like 12 times 2 over 25 times 2, what we did is we factored these pieces first, okay, and this one as well, and then we cancel reduce by forms of 1. In multiplication and division, in this respect, with fractions, our goal is to cancel to a form of 1, okay? And later you're going to see we're going to create forms of 1 here soon. So if I have x over x, that cancels to 1. If I have x squared over x squared, that cancels to 1. If I have x minus 3 over x minus 3, this whole thing, okay, as a whole piece cancels to 1. This binomial cancels with this other binomial. And those parentheses are important. Please, please, please understand that these two do not cancel to a form of 1, and these two do not cancel to a form of 1, okay? They don't do that separately. They can only cancel between multiplication pieces. And I'm showing you right here on this first example. All right, so now that we have the basis and the understanding of what's really going on with multiplication division, these are just an extension of what we've done before, okay? So let's go ahead and begin. So the first thing is, just like here, we factored, we're going to factor the top and the bottom. So the top will factor to x plus 5 and x plus 2. Okay, and then the bottom will factor to, let's see, x minus 5 and x plus 2. Okay, so just a quick review. Remember, these two will multiply to get this last term. The first two will multiply to get this first term. And then the inside and outside, this 5x and this 2x, add to get that 7. Okay, and the same thing is happening on the denominator. Okay, we have these two, negative 5 and a positive 2, multiply to get a negative 10. We have x and x that give me x squared. We got to be careful where we put this subtraction because a negative 5 plus a 2x is going to give me a negative 3x. Okay, so what we've just done is this step. We've just completed the factoring step. So now you can see, like over here, this cancellation form of 1, there's 1 right there. Okay, again, this entire thing is going to cancel with this entire thing, not a piece of it. It has to be the entire piece because you cancel between multiplication pieces. Look, there's multiplication right here and here and here. That's how you can basically cancel or chop off this binomial and this binomial with each other. And that's a cancellation form of 1, just like these over here. Okay, so what are you left with would be x plus 5 over x minus 5. There's nothing else that I can cancel with. Please, please, please do not think that you can cancel this to 1 and cancel this to a negative 1 so that you get 1 minus 1 is equal to 0. That's not how it works. It either all cancels in parentheses with the same thing on the bottom or none of it cancels. Okay, you can't go inside these parentheses and try to see if you can cancel little pieces. Okay, so when you see this right here, I want you to understand that this is a binomial up top, although parentheses aren't written. If you wrote them, then you can see, oh, this entire piece is different than this entire piece. Therefore, I can't cancel it. Okay, again, last but not least, one more reminder, you can only cancel between multiplication pieces. Okay, so our answer is going to be x plus 5 over x minus 5. When we get simplified answers like this, we always want to have no parentheses left over. Okay, so x plus 5, x minus 5 is the full thing. And now comes the fact of, we're going to say restrictions. Okay, restrictions. So these restrictions are talking about pieces or places where you cannot divide by 0. So dividing by 0, we know is a no-no. We can't divide by 0 because it's undefined. It gives us an undefined domain right there. It gives us an undefined piece at that specific location. Okay, so in my factored form, this will tell me what my restrictions are immediately. And just a quick review from last week, this would be a removable discontinuity or a hole in the graph. But nonetheless, I cannot at -2 have an x value because then I would have 0 for the denominator because -2 plus 2 is a 0, and 0 times this entire x minus 5 would give me the whole denominator being 0. Okay, so I also cannot have at x is equal to 5 because it would make this binomial factor equal 0, which would multiply with this one and give the entire denominator equaling 0. Okay, so remember, I cannot be dividing by 0 at any point in time. Okay, so if you just looked at the answer and you said, oh, well, I know that the restriction is 5, well, you would get half credit. You need to make sure that you account for all restrictions, and the best place to do it is when it was originally factored. So at 5 and -2 would be the restrictions. We could say that right here, restrictions, and that's where your undefined pieces would happen. Okay, so now let's keep going. What is the rational expression here at the bottom? Okay, so we have 24x cubed y squared over all of that, and we're going to try to simplify it in its most simple form. Now, immediately what I want to do is, aside from copying it, is I want to mark in red where the multiplication happens. Okay, where does multiplication happen? Well, it's 24 times x cubed times y squared, and -6 times -6 times x squared times y cubed. Where these red dots are at are multiplication pieces. That means this entire thing, although it looks like 3 different terms, it's actually only one term. And the reason why it's one term is that these multiplication pieces are kind of gluing this piece with this piece with this piece all together, if you will. Like if you had 3 different color of clay pieces, and I'm talking about like Play-Doh, if you were to mash them up all together, you still have one huge piece of Play-Doh. So multiplication glues these terms into one term still, okay? So 24 is a monomial, x cubed is a monomial, y squared is a monomial. That means one term. Mono means one, okay? And again, multiplication glues it all to remain as one term. Very, very, very important. Okay, same thing is happening on the bottom. You have one term that is glued together by multiplication. Okay, so this -6 monomial is glued together with x squared, is glued together with y cubed, so that it becomes, again, one term on the bottom. And the reason why I say this is because now all we have to do is identify the multiplication pieces and cancel in between. Okay, so we've done this before. When I have 3 x's on the top, 2 on the bottom, it's going to be subtraction 3 minus 2. Or you can say I had 3 x's up top, 2 on the bottom. This is what we're doing. Cancellation forms of 1. That means I only had 1 x remaining up top. I have 2 y's on the top, and I have 3 y's on the bottom. Here's another cancellation form of 1 and 1, so that I have 1 y left over in the denominator. Okay, so now we're going to look at 24 and 6. So how does 24 and 6 reduce? Well, I can divide 24 by 6 and get 4 as a remainder. And then I can divide the 6 on the bottom by 6 itself so that I get a -1. So my answer becomes a -4x over y is fully reduced. Or you could just put 4x over a -y. It means the same thing. Okay? Or because it's one term, if you want to put negative and then this entire fraction, it can be drawn like this. Now, subtle differences, but highly important. This negative written way out here in front of the entire fraction is saying either I can apply that negative to the numerator, which would make it look like this, or I could apply this negative right here to the denominator, which would make it look like this. So either one of these three are acceptable answers. Just make sure that you understand that whenever there's binomials, it can look different. Like let's say we had x minus 3 and it was over 5. Okay, and I had a negative out here. So if I made it look like this first one, it would be -x minus 3 with parentheses. Or if I made it look like the second one, it would be x minus 3 over a -5. Or it's looking like the third one right now in its state right here. So if I have a negative like this, it has to be way, way out in front, not showing that it's in the numerator or denominator. This is correct. But if I distribute it to the numerator, this would ultimately become a -x plus 3 over 5. This is probably what you're going to see as far as problems in the future. Or you'd see x minus 3 over -5. Okay, so again, these are all equivalent because of the fact of how did I apply that negative to the final answer. Okay, so anyone, for this particular one, I just wanted to give you a binomial one right now as far as an example. These three, any one of those are an acceptable answer for this particular problem. Okay, and now let's talk about the restrictions that it cannot be. So in our original piece, our original factored form, if you will, you could say that this was a factored form because they're all kind of broken up, although glued together as one term. I just have to find the values where the denominator would equal 0. Okay, so here if x is 0, because of multiplication, it makes the whole thing 0. Okay, and here as well, if y is 0, then it makes it multiplied with anything else will become 0. I cannot divide by 0. Those are my restrictions. So we're going to say the restrictions, okay, are going to be at x is equal to 0 and y is equal to 0. So when you list restrictions, you're basically saying this. Although these are my answers, you're saying x cannot equal 0 and y cannot equal 0. Those are the restrictions there. Okay? So let me come up here and fix that just real quick. Restrictions happen when x is equal to 5 and -2, but we're going to do the same thing here, okay? We're going to say x's cannot equal 5 and x's cannot equal -2. These will be listed as my restrictions, okay? Because otherwise you'd be dividing by 0. Let's keep going. Now, what is the product? Product means multiplication. of these two pieces. So all of this, I want to, again, identify where do I have multiplication happening, because I can reduce when multiplication is happening. Okay, so here we go. I have multiplication, of course, here, and then here, 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 and here. So all of this is one term because it's glued together. All of this is one term because it's glued together. And because division is a form of multiplication, this technically is one monomial. So this is one monomial, this is one monomial, glued together because of that division makes this whole thing one monomial, okay? There aren't any addition or subtraction signs. That's when you really start to see, oh, addition and subtraction pieces, then there could be more than just one term, okay? And because of this multiplication, we could say the whole thing is one term, okay? So now we're going to go ahead and break up pieces that we can identify right now. Because of the fact that this is one huge, huge fraction, we can say that what we're really looking at is 3x 49y all over 35y and 12z. Okay, because everything is glued with multiplication there, there, and there. So really, I'm just looking at one huge fraction that I can see already. Because multiplication exists between the pieces, ooh, I can cancel that form of 1 right there. So those y's are gone, okay? And then I start to see other pieces that I can reduce or cancel, okay? So let's look at these numbers per se. The 49, we know, again, we have to factor it. That's the best thing to do to identify what it was going to cancel, reduce, to 7 and 7. I can see this 35 can be factored to 7 times 5. And I can see this 12 could factor to 4 and 3. And the reason why I chose 4 and 3 is because, look, I can cancel now these 3's to a form of 1. They're gone. Okay? This 7 is for this 7. That's gone. So now all I have left over in the top is x and 7. And on the bottom is 5, 4, and z. Well, 7 has nothing in common with 5 or 4. So there aren't any other identical copies or common factors between the top and the bottom in the numerator and denominator. So when you can't see, ooh, that the way you canceled all these pieces before, there's nothing else to cancel, well, then you just got to multiply straight across. X times 7 is 7x. Multiply straight across all the pieces that are left over, okay? So we have 5 times 4 is 20z. And this is going to be in our simplest form. Okay, so we have 7x over 20z. This is our simplest form. So basically our answer, if you will, the expression that is. And we want to state restrictions. Again, restrictions are only when the denominator is equal to 0. But please do not just go off of the answer. Go off of the most factored form of the original problem. So the most factored form of the original problem could be either here or here. So what values for all the variables, just the variables. So I have a variable of y and I have a variable of z. Okay, that's whenever you're going to restrict or name your restrictions. Okay, because just because they disappear doesn't mean that you don't have to account for them as far as restrictions. So y cannot equal 0. And z cannot equal 0.